Solving quadratic equations. A question I always get is, why do we even have to know how to factor? Simply put, critical thinking skills and creating solutions. So here's a story. A rock is launched vertically into the air from the ground at a initial velocity of 80 feet per second. How long will it take for it to hit the ground? So before you get overwhelmed, it's always good to read and understand the scenario. What do you know from reading the prompt? Have you ever experienced or seen a rock or any type of object thrown vertically into the air? All of these things will help in your comprehension of the scenario itself. So let's think about what we know. Number one, we know the rock will launch fast. We know the rock will keep going higher. It will slow down the higher it goes. It will stop for a brief moment and hit its highest point. The rock will then begin to fall and pick up speed as it makes its way back down to the ground, and then it will finally hit the ground. And these are the things we all understand from experience. All you have to do is think about the details of what's going on. Okay, let's say you still don't see the connection between this scenario and factoring quadratics. This is where your imagination will play a very important role. So let's pay close attention to what's about to happen next. It launches at 80 feet per second, slows down to hit its highest point, then makes its way back down, and then it hits the ground. So things like this happens around you all the time. And all of this can be explained through math. All right, so now we're going to get in how we calculate the time that the rock hits the ground. All right, so let's go back to the scenario. And remember, the bottom line is we want to know how long will it take for it to hit the ground. So I have a generic formula that we're going to use to calculate. V sub 0 is for initial velocity and S sub 0 is for initial position. And remember, hitting the ground means the height will hit 0. If we input all the given information into the equation above, it will establish the height relationship to time. Now it's time to solve the quadratic. By dividing everything by negative 16, I would then get t squared minus 5t plus 0. And if we can find two numbers whose sum is 5 and product is 0, then they will be all the solutions to this quadratic. And remember, two numbers will have an average of 5 if they both were 5 over 2. So I have 5 over 2 plus u times 5 over 2 minus u. Multiplying both fractions, I get 25 over 4. Multiplying both variables, I get minus u squared. And I set it equal to the product of 0. Now I can add u squared to the right side, and that leaves me with 25 over 4 is equal to u squared. Square rooting both sides, u would then be equal to 5 over 2. So what we have found is the unknown number. I can now substitute my unknown numbers where I highlighted, and that gives me 5 over 2 plus 5 over 2, which is 10 over 2, and that is equal to 5. Then I have 5 over 2 minus 5 over 2. That gives me 0 over 2, also known as 0. So 5 and 0 are my solutions. So at 0 seconds, my rock is at the ground level, then it's launched, and in 5 seconds, it hits the ground again. Very important note. Remember to always answer the question that is asked. The rock hit the ground 5 seconds after it was launched. So this is my process that I follow. Number 1, try to visualize to comprehend. Number 2, use math formulas or equations to compute. Last but not least, have your conclusion.